So this week with the 2 half days, we're only going to do 10-1 and 10-2. The half days are going to be review days. Whatever time we have, we'll just go over what we did the previous day. So the main topic for this week is solving systems, which means when you're solving an equation, if you have more than one variable, that's called a system. This is a 2-variable system, so when you're done it, you need to have an answer for x and an answer for y. That is a 3-variable system. So when you're done that one, you need an answer for x, y, and z. And you can get partial credit for each answer you get right. There's 3 main methods we're going to look at using this week. I'm going to show you guys how to do substitution. Then I'm going to show you how to do elimination. And those are the only 2 today. When you get a system that has more than 2 variables, there's a different method that works in a more organized way. Because that's, I think, one thing people struggle with when you get to 3 variables is you just have lots of choices. And if you don't make the right one, it's not that you'll get it wrong, but it could make the problem a little bit harder. So a system of equations is when you have 2 or more equations and you're solving for 2 or more variables. In the problems that I give you, you will always have the same number of equations as variables. So if you're solving for 2 variables, I will give you 2 equations. 3 variables would be 3. So the first problem we're going to do, we're not even going to solve it. We're just going to set it up, and then we'll solve it next. So rectangle problems, they come up quite a bit, and the 2 formulas that you need to know for rectangles are the formula for the area and the formula for the perimeter. So we'll go through those right now. We're just going to set it up. And then we'll look at solving it in the next example. So it says find the length and the width of a rectangle if the perimeter is 100 and the area is 300. Well, when you're dealing with a rectangle, what are your 2 things that you have to know about it? If you're going to draw out a rectangle, you would need to know these 2 things to be able to draw it or to build it. Yeah?
There's 2 sets of equal sides.
Okay, so like let's say I want you to actually make a rectangle, and I hand you a bunch of 2x4s and I say make a rectangle, but I want it to be the one I'm thinking of in my head. What do you need to know? You need the length and the width. Yeah. So those are going to be your 2 variables when you're dealing with rectangles, length and width. So we use x and y a lot, but in a word problem like this, I would use L and W for your variables. All right, let's start with the perimeter. So here we can use an idea that Chad said. We got 2 pairs of equal sides. Okay, here's the length. Here's the width. So what's the formula for the perimeter of that rectangle? Yeah.
Would it be 2L plus 2W equals 100?
So 2L plus 2W. Yeah, and we'll fill in the 100 in a second. So there's your formula for perimeter of a rectangle, in case you didn't know it. And how about the formula for the area? Yeah.
Length times width.
Length times width. So those are the 2 formulas that we need. We just have to fill in the letters in the right spots. What do they tell me the perimeter is in this one?
100.
100. So 100 equals 2L plus 2W. And what do they tell me the area is? 300. Yep. So that is how you would set up your system of equations. And you do need both of them because let's say I just told you I want you to build a rectangle that has an area of 300. Well, there's lots of ways you could do that. Right? You could make it 10 by 30, because 10 times 30 is 300. You could make it 150 by 2. You could make it 103, 100 times 3. So even though there's lots of different rectangles that might have an area of 300, it also has to have a perimeter of 100. So that's gonna narrow down how many answers there are. All right, so any question on setting that up? Now, when we go to solve it in the next problem, I think I do change these to x's and w's, like 2x plus 2y, and 300 equals x times y. All right, it doesn't matter what letters you use, but x and y we use quite a bit. So these are the two methods we're going to use to solve. I would say in a problem like this, we're going to use elimination. Oh, no, not elimination, substitution. Elimination would be not a good method to use with this one, and I think once I explain that method, you'll know why substitution is a much better way to solve this one. So how do you do substitution? So there are some choices. Okay, the first step is you're going to pick an equation to work with. The second thing you're going to do is you're going to pick a variable to work with. And the goal is going to be to get one of the variables in one of the equations by itself. Which equation here do you think would be easier to get a letter by itself in? The top one or the bottom one? Yeah, I would say the bottom one. Definitely going to be easier to get the variable by itself. As far as which variable in the bottom, they're both pretty much the same. Okay, but that's the first step. Pick an equation, and then you're going to get a particular variable by itself. Once you get that variable by itself, you're going to take that result that you got from step 1, and you're going to plug it back into the other equation. Okay, that's why this is called substitution. Because you're going to do something in one equation, and you're going to plug that back into the other one that you didn't use. Once you get to step 2, you should know the answer for one of your letters. Depending on how you did it, you're like in this one, you're either going to know the L or you're going to know the W at this step. Once you have one of your answers, like let's say you find W is 10, all you have to do is take that now and plug it back in, and then you can solve for the other letter. So once you get your first letter, the second letter is pretty easy. The key to remember is you are finding two answers. Okay, one answer for L, one answer for W. Okay, or as you'll see in a sec, we're going to just call them X and Y. So that's the same problem that we set up. I guess we'll call this like example 1A. And then example 1B will be where we solve it. All right, so pick an equation, solve it for a variable. Which equation do we think is easier to solve there for a variable, top or bottom?
Bottom.
Yep, bottom. Okay. What letter do you want to get by itself in the bottom?
X.
X. Okay, so when we're done, we're going to have something in that box. To get X by itself, that means you need to put the Y on the other side. How would you move the Y from the left side over to the right side?
Divide it.
Yeah, you divide each side by Y. So what would be in that box?
300 over y.
300 divided by Y. Any question on how we got X by itself in the bottom? Okay, that's the first step. Now, it says to plug in the result's what's in the box, into the other equation. What letter is this going to get plugged in for?
X.
Yeah, it's going to get plugged in for X in the top equation. So let's do that and then see what happens. So we got 2y plus 2 times, And now you're not going to put x back next to the 2. You're going to fill in 300 divided by y. Okay, now look at that equation for a second. How many different letters are in the equation now?
One.
Just one. Okay, that's the whole goal of substitution. It takes a problem that had 2 different letters and it turns it into just having 1 letter. It's used twice, but it's still just one different letter. Okay, so first step. If it confuses you to multiply something that's a fraction and something that's not, then think of them both as fractions. When you multiply straight across, what's 300 over y times 2 over 1?
600 over y?
Yep, 600 over y. And now, let's see. What's kind of annoying about that is that fraction. What's making it a fraction is the divide by y. What could you do that would cancel out dividing by y? Yeah, you can multiply by y. But you have to do it here, here, and there. So if you multiply everything by y, it's going to get rid of that fraction in the middle. What's 2y times y?
2y squared.
2y squared. And then in the middle, divided by y times y, that's gone. Plus 600. And on the right side, 100y. So now we have an equation similar to things we've worked with before. The highest exponent in that equation is a 2. And when the highest exponent is a 2, what kind of equation does that mean it is?
Quadratic.
It's quadratic. So we can either factor it or we can use quadratic formula. Regardless of the method, what do you always have to get a quadratic equal to when you're solving it?
0.
Got to get it equal to 0. So let's, how would you bring that 100y to the left side?
Subtract it.
Yep. Now this next step, it's not necessary, but it will make the numbers a little easier to work with. If they're all divisible by the same thing, we can divide everything through by that number. Are all the coefficients divisible by anything?
2.
2, yeah, they're all divisible by 2. So solving this problem is exactly the same as the one above. It's just the numbers are a little smaller. Okay, now, I don't think that that's going to be factorable, because we're looking for 2 numbers that multiply to give us 300, and then add or subtract to give us that 50. Well, it's a big number, so it could be hard to try and factor it. So what's the other method we can use if you can't factor it?
Quadratic.
Yeah, so let's try that. And if we get a nice answer with the quadratic formula, that's fine. It just means we could have factored it instead of using the formula. Okay. What's A going to be in this one? 1. B? And C? 300. Okay, so just a reminder, quadratic formula. Okay, as I go, I'll do some of it out, so we don't have as many steps to write. So negative b plus or minus negative 50 squared. How much is that? 20. Yeah, it's like 5 squared with 2 more zeros. So 2,500 minus 4 times A times C. So 4 times A times C. Well, A is 1. And what's C?
300.
300. And we're going to divide by 2. All right. So now we'll just type that in and round it off, see what we get. Okay, and remember, this is the answer for which letter are we solving for?
Y.
Yeah, solving for the y. All right, so let's put that in. So we've got 50 plus the square root of, what's 4 times 300? 1200. So that's going to be the square root of 2500, take away 1200. Well, 25 take away 12 is 13. So square root of 1300. So that's the numerator. And then divide by 2. So 43, we'll say 0.028. 43.028. Now, why did I write y1? Because what else do I have to type in to get the other answer for y?
The minus.
The minus, yeah. So 50 minus the square root of 1300. Unless it comes out negative, then I won't need that answer because you can't have negative width or negative length. It doesn't come out negative. 6.972. So that's the answer for the y. All right. Now, what else do we need to find when we are solving a system? What is it? Yeah, we still need the x value. But once we have the y, then the x is easy. We know you could use either one of these to find the x value. Which one do you think is going to be simpler?
Bottom.
Yeah, the bottom. We know that x times y equals 300. Okay, that's the one we solved originally. If you look at the formula, we're trying to solve for x. We already have a formula right there for x. Just take 300 and divide by your y. So let's find x1. And I should put approximate because I did round those. They're not exact answers. So the x is 300 divided by your y. So 300 divided by 43.028. Look at what I get, 6.972. Anybody have a guess what I'm going to get for x2? Yeah, let's check it. Take 300 and divide by your y. 6.972 is 43, well, 029. It should be 028, it's just rounding. But 43.029. If I rounded to 2 decimal places, then they would be the same, 43.03, 43.03. So we do get 2 different answers, but in terms of the rectangle, all that these 2 answers mean is the first answer you're thinking of it this way, and the second answer you're thinking of it that way. It's the same rectangle, but it's just turned a different way. But technically that is a different answer. That is a different answer. All right, so any questions on how we found the first answer and the second answer? And you can write it like that. A lot of times I just put it in a table if there's more than one answer and just organize it like that. Whoops, I meant to put a 2 there. Sorry about that. So the top row is my first answer, bottom row is my second answer. Now, not every problem ends up being a quadratic. Right? This one did, but I'll tell you most of them are a little bit easier than that. Question on that one? Okay, let's try another one with substitution that is not a quadratic. Now, sometimes there is no obvious equation you should work with. In this one, I think there is. There's definitely an equation you could work with and get a letter by itself. That would be less work. Which equation do you think we're going to work with here and try to get a letter alone? Yeah. Yeah, we're going to work with the first one. And which letter do you want to get by itself? Well, you could do X or Y, but I think one of them is definitely easier. Which one did you say? Y. How come? Because there's what?
It's already low.
Yeah, if you look for the variable that already has a coefficient of 1, that is the easiest letter to get by itself, because then you don't have to divide by the number in front. Okay? If you wanted to get X by itself in the top, you'd end up dividing by a 2. And is the number on the other side a multiple of 2? No. So now when you do that, now you have fractions and decimals. All right, so we'll stay away from that. So we're going to get Y by itself in the top. And if we get Y by itself, can anybody tell me what would go in the box?
Y equals negative 2x plus 5.
Yep. It's not necessary to put it in Y equals mx plus b. That's good. If you wrote 5 minus 2x, that would also be fine. But yep, as long as you got a negative 2x and a positive 5 on the other side, that's what we're looking for. All right. Now, where is what's in the box going to get plugged in? For Y, where?
On the second.
In the second. Yep, so take that and fill that in right there. Okay, whenever you substitute in something from the other equation, keep it in parentheses. Why do you think I need parentheses for what I'm about to fill in for Y? Yeah?
Because it's being multiplied.
Yeah, because it's being multiplied, and you have to multiply both of these things, okay? Because it's a distributive property. Okay, so what we get, 3x, that stays the same. The plus stays the same, the 2 stays the same, and the equals 2 stays the same. I just substituted in what's in that box for negative 2x plus 5. And this will not be a quadratic. Just a linear equation. All right, what's my first step there?
Distribute.
Yep, I'm going to distribute. And can anyone tell me what we get when we distribute out that 2?
Negative 4x
Negative 4x
plus 10.
plus 10. All right, now our next step is just going to be something on the left side. It's not something on both sides.
Combine all terms.
Yep, all we can do is combine like terms. What's 3x? Take away 4x.
Negative 4x.
X. Right, now the next step involves moving something to the other side.
Minus 10.
So minus the 10. 2 take away 10 is negative 8, but that's not x. That's negative x. Yeah? Yeah, you can just divide each side by negative 1. And we get x equals, what's negative 8 divided by negative 1? 8, perfect. And there is not a second answer for x, because this, yeah, it's not a quadratic. Okay, so let's scroll back up. Are we all done?
No.
No, what do we still need?
We'll
Y.
get back in.
Yeah, we still need y. So we're going to take that, and we're going to fill it back in right there. So we've got negative 2 times x. And what did we just figure out x is? 8. Okay. What's negative 2 times 8?
Negative 16.
Negative 16. And negative 16 plus 5 gives me?
11.
Negative 11. So y equals negative 11. Now, if you were to draw each one of these on the calculator, this one and that one, they're both lines. They'd both be lines. What would happen at the coordinate 8, -11?
They intersect.
Right, it's where they intersect. We're not looking at drawing it and finding the intersection point, but that's exactly where they would cross each other. All right, any question on that one? All right, so that's substitution, okay? And that's a pretty typical substitution kind of problem. All right, I don't spend a ton of time on it because you did that back in Algebra 1, and you probably reviewed it again in Algebra 2, so it's probably the third time you've done it. Okay, so elimination. So elimination is a little bit different method. And it works well if they give you a problem where your x's are lined up in a column, your y's are in a column, and then the numbers on the other side without any x's and y's are in a column. And the goal of elimination is to try to make one of the letters cancel out right away. And the way that we can get a letter to cancel out is by using what are called linear combinations. All that a linear combination is it's a multiple of an equation. So like if you have this, let's add a y in there because we're doing 2 variable. This is a linear combination of that equation. What did I do to get that?
Multiply by 2.
Yeah, I multiplied the whole equation by 2. You can multiply an equation by any number that you want, except 0. You can't multiply by 0. But the goal is to somehow make it so that one of the letters in your first equation is the opposite of that letter in the second equation. So if you had a 3x in the top equation, you somehow want to get a negative 3x in the bottom equation. You want them to be opposites. And in order to get them to be opposites, a lot of times you do have to multiply an equation by a number to make that happen. Now, even though you can multiply by any number that you want, generally we try not to multiply by fractions because that's going to get kind of messy. Okay, so we're not going to solve this one. I just want to practice kind of multiplying. Let's say you had something like 2x plus 3y equals 5. And let's say we had x plus 4y equals 6. And I wanted to try to eliminate a variable there. In order to get the coefficients to be opposites, you pick a letter to start with, either the x's or the y's. Anybody know which letter would be easier in this case? Yeah?
The x's.
Yeah, the x's. The coefficient of the top x is a 2. What's the coefficient of the bottom one? It's a 1. If I want to get those x's to cancel out, I need these two numbers to be opposites. Which equation could I multiply by a number and it would make it the opposite of one of them? Would I multiply the top equation by a number or the bottom?
The bottom.
Yeah, we could multiply this bottom equation by a certain number, and then the x's would cancel out. What would that number be?
Negative 2.
Negative 2. So if we distribute out negative 2, the top equation stays the same, but the bottom one would become, what's 1x times negative 2? Negative 2x minus 8y, and 6 times negative 2? Minus 12. Now, we add the columns up. That 2x and negative 2x is gone. What's 3y minus 8y? Yep, negative 5y. And what's 5 plus negative 12?
Minus 7.
What is it?
Negative 7.
Negative 7. And once you get to that step, the only thing left is usually to divide by the number in front of y. What would we divide each side by here?
Negative 5.
Negative 5. And what would y equal? And we'll just leave it as a fraction.
7 over 5.
7 over 5. Okay, I'm going to stop with that because we didn't get that great of an answer. It's kind of messy. So now we would take that number and we would plug it back in to either equation. That part is like what we did before. So we start out a little different, but then we still use substitution to finish it. All right, any question on that idea? Let's try it on this one. Okay, so the way I decide which letter to work with is I usually start by looking at the x's, and I say, is there something I can multiply the smaller number by to make it the bigger number, or the opposite of the bigger number, and not use a fraction? So is there anything I can multiply 2 by to make it 3?
No.
If that was a 4 in the bottom one, then yes, I could. Let's look at the y's then. Look at the smaller number. Is there anything I can multiply 3 by without fractions to make it a 5?
No.
No.
No. So in that case, we're going to have to multiply both equations by a number. So put the number I'm going to use in that box. I'm going to need another number in that box. And now we have to decide, do we want to make the x's cancel or the y's? Okay, we're going to make the x's cancel. Then we need this number and that number to be opposites. The easiest way to do that is to find a number that both of those divide into. Okay, 6. So let's try to make one of them a 6, and let's try to make the other one a negative 6. How could we make the top one a 6? Times by 3. And how could you make the bottom one a negative 6? Times by 2. All right, so let's do that out and look at our new equations. What's my new top equation going to be when I distribute out the 3?
6x plus 9y
6x plus 9y.
equals 15.
Yep. Okay, some people forget to multiply the other side. Don't forget the 5 times 3 is 15. Okay. And how about the bottom equation?
Negative 6x plus 10y
10y
equals 12.
equals, say that again?
12. Oh, shit.
42.
Oh, is it 21? I'm
Yeah.
retarded.
Yeah.
Why do I have a 6? JK.
Huh? Okay, so now when you add up these columns, what cancels out right away? Yeah. X's are gone. And what's 9y plus 10y? Okay, we got 19y. And what's 15 plus 42? 57. Okay, when we look at that, we might think it's not going to come out nice, but actually that will come out to a nice answer. What are we going to divide each side by?
19.
19. All right, and what does that give me for y? Yep, gives me y equals 3. Depending on how you set this up, you could have chosen to eliminate the y's first, and then you would have gotten x as your first letter. Okay, it doesn't matter which letter you eliminate first. Okay, so now we've got y. What's the last thing we need to find?
X.
Yep, we got to find x. And does it matter which equation we use?
No, it doesn't matter.
It doesn't matter. I would pick one of the original ones because we know the original ones are correct. And I would pick whichever one you think is easier to work with. Do you want to work with equation 1 or equation 2? Okay. So what are we going to plug into equation 1? We're going to plug in for y and what number? 3. So we're going to have 2x. What's 3 times y? 9. And then next step, minus 9 on each side. 2x equals negative 4. And then x would give me negative 2. And there you go. Not every answer is going to come out to fractions. You might get some that do and some that don't. Okay, this one did. Question on that one? So I think I had maybe 1 or 2 more of those, and then we're going to just finish up with the 3 variable. So think of these problems when we draw these. What shape did we say these 2 things would be? Right, linear. They're lines. The kinds of problems we've done so far would look something like that. They would cross in exactly one spot, and the spot that they would cross in would be the coordinate that we just found, negative 2, 3. What's something else that could happen with 2 lines when you draw them instead of that?
They could be parallel.
Right, it could be parallel, which means when you go to solve them, what would you get for an answer?
No solution.
Yeah, you get a no solution. So that can happen. What's a third thing that can happen? Yep.
They can be touching at all points.
Right, they could be touching at all points, which means they're the same line. How many answers would you get there?
Infinite.
Infinite, yeah. So you can get a 1 solution. That's the kind of problems we've done so far. A no solution if they were parallel. And an infinite solution if they were the same line. Okay, so let's try one of the cases we haven't done. And then we'll finish up with the 3 variable. Okay, so again, visually, you don't have to worry about drawing it because we're not doing sketches. But I think the visual helps it make sense why you could get no solution, because it's lines that don't cross. Okay, you don't necessarily know right away if it's going to be a no solution or an infinite solution. So you just try solving it the way you normally would. Okay, so which letter do we want to try to eliminate in this one? X, sure. You can eliminate x. So if you're going to eliminate x, look at the smaller number. Can you multiply it by something to get the bigger number?
Yes.
Yes, then I would say that's a good one to do. What could you multiply the top equation by?
3.
3. And because you can do that, and it'll directly give you the opposite of the number in the bottom, you don't need to multiply the bottom. So what I'm going to do, I'm just going to copy it. I'm going to do 6x plus 9y equals 10. And what's my new top equation?
6x
Minus 9y equals 15. Let's add them up. What's 6x and negative 6x?
Cancels.
That cancels. What's negative 9y plus 9y?
Cancels.
That also cancels. So we got to have something over here.
A 0.
So yeah, we don't have anything left. 0. And now add up the column on the right. 25. So when all your variables cancel out, you are done. We now just have to interpret what that means. It's a special case. What does 0 equals 25 mean? Yeah, that's a no solution. If you were to draw these 2 lines by getting y by itself and putting them in on the calculator, how would they look?
They would be parallel.
They would be parallel. Yep, these are parallel. So that's why it's a no solution. Any question on that? So what I'm basically doing, I'm giving you one of each type. Okay? The one solution we did right there. We just did the no solution right there. Now let's try that one before we go to the last thing. All right. Which letter do we want to try to eliminate this time? Sure. What's the coefficient in front of x in the top? 1. Is there something you can multiply by to make it the opposite of the bottom?
2.
Yeah, then I would say that that's a good one to use. So put a 2. That's what we're going to distribute. What do we distribute in the bottom? Nothing. It stays the same. So not every equation involves changing both of them. Sometimes it's just one. So 2x 6y equals 1. And what's my top one going to become?
2x minus 6y equals -4.
Okay. All right, let's add up these columns. 2x and negative 2x. Negative 6y plus 6y. So what's on the left side? 0. Negative 4 plus 4. So we get 0 equals 0. What does that mean? Yeah, that means when you get the same thing on each side, that's a true statement. The last one was false. Since that's true, we have infinite solutions. What that means is any number is an answer to this problem. 6, 2.4, negative 5/7, any number is a solution. If you were to draw these on the calculator, how would they look?
They'd be on the same line.
Yeah, they're exactly the same line. That's why there's infinite solutions. Okay, so those last two, those are special cases. Those don't come up as often. Any question on that? All right. So the last thing we're going to look at is the 3 variable. Even though it's only one more variable, it's a lot more steps. The steps aren't any harder than 2 variable. It's just basic multiplying an equation and trying to get a letter to cancel, but there's more of it to do. So it's not really harder, it's longer. So I'm going to explain what we do first, and then I'm going to try to organize it and show you an example. So in a 3 variable system, you're going to be given 3 variables, and you're going to be given 3 equations. We're going to pick one variable to eliminate in 2 of the equations. So we're going to forget about one of the equations in this step. We're only going to use 2 equations, and we're going to try to eliminate a variable in 2 of them.
Could we pick any of the 2?
You can pick any of the 2, but certain choices are going to make this problem a lot easier than other choices. But yes, technically you can pick any 2 equations, and then once you pick those 2 equations, you can pick any letter you want to eliminate. And that's where I think some people start to get a little bit confused because there's lots of choices. You could pick equations 1 and 2 and try to eliminate x. You could pick 1 and 2 and try to eliminate y. You could pick 1 and 3 and try to eliminate z. Right? There's lots of options here. But this one is set up so there is one option that's going to be the easiest.
1 and 3 for x.
Yeah, we'll talk about that in a second. But yeah, we definitely want to do something with this because it's the only letter that doesn't have a number in front of it, and that's going to make it easy to work with. So you're going to pick a variable, and you're going to eliminate that variable in 2 of the equations. And let me reword that a little bit. Okay, so pick one variable to eliminate in 2 of the equations. And now, pick 2 different, that's the key. You can't do the same 2 again. You're just going to get the same answer. Pick 2 different equations. And you have to eliminate the same letter again. this point, you are now going to have two equations with two letters in it, and it's going to turn into a problem just like that. Then from there, we know how to solve it. Okay, so pick two different equations and eliminate the same letter again. Now, solve like you would a two-variable problem. What does that mean? Use substitution if you want to do that, or elimination if you want to do that. I will tell you, elimination is probably going to be the way to go. Okay. So I have something I can kind of refer to and explain what we're doing at each step. When I write a number and I circle it, that's going to represent an equation. So like a 2 circled is going to be equation 2. 3 circled is equation 3. So let's pick 2 equations to work with, and we're going to try to get rid of a letter. What do you think? I kind of gave you a hint already. But what do you think a good letter to try to eliminate would be here?
X.
Yeah. The reason we want to try to get rid of x is because this has a 1 in it, and I can easily multiply 1 by something to make it -3 and get something to cancel. And I can easily multiply 1 by something and make it a -2 and get something else to cancel. Okay, those are going to be separate steps. So we're going to eliminate x. And which 2 equations do we want to do that in first?
2 and 3.
2 and 3. Yeah, you definitely want to use 3. So let's eliminate x in equation 2 and 3. So there is a lot of copying. Okay, what I tend to just copy it down again, so I kind of have it where I'm working. So we've got 3x minus 2y plus 2z equals 15. And if you notice me copy something wrong, let me know, because that's not good. All right. We have a 1 and a 3. Can we multiply 1 by something that would make it cancel out 3?
3. Yes.
Yep. What would you multiply it by?
-3.
-3. Here, 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 and there. And we're going to multiply by -3. Okay. What's my new equation going to be for the top one?
So they're the same.
It stays the same. So I'm just going to copy that over. 3x minus 2y plus 2z equals 15. And what's my new equation for the bottom going to be? -3x, yep,
Minus 12y.
minus 12y
Plus 9z.
plus 9z, yep,
Plus
equals
24.
24. This is all it's going to be for the whole problem. So it's just doing this like 4 or 5 times. But that's why it takes longer. Okay, what's 3x and -3x?
Cancel out.
Cancels out. What's -2y plus -12y?
-14y.
We didn't expect those to cancel. That's not what we were trying to do. What about 2z plus 9z? Plus 11z and 15 plus 24?
29. Wait. 39.
39. Okay. So I'm going to put a box around that. We don't need it right now, but we will. We're going to come back to it. And I'm going to call that equation 4. That's a new equation that I just made, and it no longer has an x in it. Now, what I need is another new equation without an x in it. I need another equation with just a y and just a z. And that's going to help me to turn the complicated problem that has 3 letters into a simpler one with 2. Okay, so now we have to eliminate the same letter again, but we have to do it in 2 other equations. So you can't use 2 2 and 3 again. So pick a different pair of equations. 1 and 3. I definitely would keep using that. So now, let's eliminate x in 1 and 3. It really helps if you write down what you're doing so it's kind of organized, and then you can follow your work. All right, so first thing I'm going to do, I'm going to copy them down. Let me make it so I can see it for now. So equation 1 is 2x plus 3y minus z equals -1. And equation 3 is x plus 4y minus 3z equals -8. And again, if you notice we copy something wrong, just let me know. I think that looks good. I'm just going to hold that over. Okay, so we're trying to eliminate x. I need these numbers to be opposites. So what number do we want to turn this into? We want that to be a -2. So what would you multiply by?
-2.
Yep. And what about in the top equation? Stays exactly the same. 2x plus 3y. Just copy over the top one. And bottom one, what's 1x times -2? -2x. What's -2 times 4y? Minus 8y. And -2 times 3z is what? Positive 6z. And -8 times -2? 16. All right, add those up. What happens to my x's? Those cancel. What's 3y plus -8y? -5y. What's -1z plus 6z? Plus 5z. And the right side, -1 plus 16? It's going to give me 15. Now, you could leave it like that. That is fine. But what do you notice about each one of those numbers? They're all divisible by 5. So if you want to make your numbers easier to work with, you can divide everything by 5. Now, if that number on the right was a 16, then I would say, no, you can't do that. But can somebody tell me, what do you get when you divide them all by 5?
-y plus z equals 3.
-y plus z equals 3. And that's what I would do at that step. Again, it's not necessary, but it will make it easier. I'm going to call that equation 5. So what we've done now is we created 2 new equations. And what letter is missing from both of them?
X.
X. Now, equations 4 and 5 is a problem just like this. Now we can eliminate a letter and get our first answer. Okay. But that's kind of the extra step with 3 variables. All right, so now let's look at equations 4 and 5. There's a letter there that I think is going to be, well, either letter you could try to eliminate. What letter do you want to try to eliminate in 4 and 5? Yeah, sure. So let's eliminate z. So I'm going to put down eliminate z in equations 4 and 5. So what's the first thing I'm going to do with equations 4 and 5? Yeah, I'm just going to copy them down so I don't have to keep scrolling up. -14y plus 11z equals 39. Negative y plus z equals 3. So to make the z's cancel, which equation is going to have to get multiplied?
Bottom one.
The bottom one. And what are we going to multiply the bottom one by?
Negative 11.
Negative 11. Perfect. What's going to happen to the top? Stays the same. There's always going to be one that stays the same. Okay? It gets kind of hard when you're doing 3 variables if you have to start multiplying both. So I'm going to try to always set them up so you don't have to do that. Okay, so negative 14y plus 11z equals 39. Okay, what's my new bottom equation going to be? Okay, 11y minus 11z equals negative 33. Okay, and now add your columns up. What's negative 14 plus 11? Negative 3y. 11z and negative 11z, what's going to happen there? Those are going to cancel out. And 39 plus negative 33?
6.
6. And how do we get rid of the negative 3 in front of y? By my negative 3. That's gone. And what's our first answer? Negative 2. Now, even though we only have the first answer, at this point, we're like 80% done the problem. Okay, that's the hardest one to get, the first one. Now, what do you think we're going to do with that negative 2 to get another letter? Yeah, we're just going to plug it back in. I would plug it into either equation 4 or 5. Which one looks simpler?
5.
Why? How come?
Because there's no negative.
Yeah, there's no coefficients in front of the variables. Right? 4 would work, but those are bigger numbers in front of the letters. So let's take equation 5, and let's fill in negative 2. So now we're going to take that, plug that in right there. So that's negative 2 plus 3 equals z. Felicity, what's going to happen there? Negative 2. It's going to become positive. And Shane, my last step to get z by itself.
Subtract 2 from both sides.
And we get z equals 1. So I told you the second answer would come very quick after the first one. And the third one will be just as quick. What's the last letter we need to solve for?
X.
Yep, solve for x. And which equation, you can pick any of them. Which one do you think would be the easiest?
3.
Yeah, I would say 3, because x is already has a 1 in front of it, so I would use that. X plus 4y minus 3z. So x plus 4y, was it equals negative 8? The last one? Yeah. So Chad, what am I plugging in for x?
What?
What am I plugging in for x?
1. Let's see. 0.
Like nothing.
Nothing.
You mean for y?
Why?
You said X.
You said X.
Yes, I did say what are we plugging in for x? Why are we plugging in nothing?
Because there's
No answer.
Yeah, but that's what we're solving for. We've already solved for y and z. We do not have anything to plug in for x. So x stays as x. What are we plugging in for y? Negative 2. And what are we plugging in for z? Plugging in 1. So simplify. Negative 8 minus 3. What's negative 8 minus 3?
Negative 11.
Negative 11. And that would mean x is
3.
3. Yep. So once you get your first answer, again, the last two are very quick. But getting to that first answer, it takes a while. But that's pretty much the steps when you have a 3-variable kind of problem. Any question on any of the steps? If you notice that you start getting really bad answers like decimals, chances are you might have messed up. Okay? Because I'm going to try to make a lot of these come out to nice numbers. Okay, I think the one on the test, it does. Comes out. When I say nice, I mean numbers without decimals. All right, we'll finish up with this one. Now, this one already has a letter missing. That's a good thing, okay? Because maybe we can take advantage of that, and we won't have to try to make that letter disappear ourselves, because it's already not there. If you can't take advantage of it, then in your head, just pretend like there's a 0y right there. And at least make the arithmetic a little easier. Okay. All right, so it's equation 1, 2, and 3. Which letter do we want to try to eliminate? Try to eliminate z? Okay. Which two equations do you want to do that in? 1 and 2. So let's eliminate z in equations 1 and 2. So I'll copy them over. And 2x. You don't have to put the 0y. You can leave it blank, or if it helps you, you can fill it in. Okay. So now, what would we have to multiply by to make the z's opposite? Nothing. They already are. So just add them the way they are. Okay. Add your first column. What do you get? 3x. Second column, minus y. Third column, z's are gone, and the numbers on the other side. 12. So that was a lot easier than the first step in the last one, because we didn't have to multiply. So that is your first new equation. Now, since we eliminated z the first time, what are we going to have to eliminate the next time? Right, we got to do z again. I'm going to do it right next to it. So we have to eliminate z. And we have to pick two other equations. It cannot be 1 and 2.
1 and 3.
Yeah, I think 1 and 3 would be perfect because the same basic thing is going to happen again. Okay, so let me copy down 1 and 3. X minus y plus z equals 6. Oh, it's right there. And 2x plus 2y minus z equals 12. Okay, what do we have to multiply by to make the z's cancel? Cadence. Yeah, nothing. They're already going to cancel the way they are. So again, that's a little bit easier than the last one. Add them up. We get 3x. What's negative y plus 2y? 1y. That's great. You got a letter with a 1 in front of it. 1's always make the next step easier. Positive z minus z. Cancels. And 6 plus 12? 18. And we'll call that one, we already have an equation 4. Let's call that one 5. All right, so now we're going to use equations 4 and 5. And I think here there's a pretty obvious choice which letter we would want to try to eliminate. Yeah, because if you just add them together, the y is just gone automatically. So this one's it's working out a lot easier. So let's eliminate y in 4 and 5. Okay, so 4, 5. And what do we have to multiply by to make the y's cancel? Nothing. They're going to cancel the way they are. So I'm showing you a little bit easier one than the last one. 3x plus 3x, 6x. And 12 plus 18, 30. So now our first answer, 6 times what gives us 30? 5. And once you get to that step, you're mostly done the problem in terms of like the elimination. Well, you're done with elimination. Now, what are we going to do with the 5 to get our next answer? Yeah, we're going to plug it back in. Do we want to plug it into equation 4 or equation 5? Yeah, we could do 4. So x is 5. So fill it in. 3 times 5 is going to give me 15. So we got to get the 15 over with the 12. And when you subtract 15, what's 12 minus 15? Negative 3. Negative 3. So Tom, what does that mean y is?
Y's gonna be 3.
Y is going to be 3. Okay, so there's your second answer. Coming pretty quick after the first one. And what's the last one we don't have? Z. So let's find the simplest one, and we'll fill in x and y. Which one do you think is the simplest one there to find z?
2.
Yeah, the second one, because you don't even need y. It's just 2x minus z equals 6. Okay, and what did we get for x?
5.
Yep, we got 5. 2 times 5 is going to give me 10. And then we put the 10 on the other side. Negative 4. Then I'm writing out every single step. Some of these you might be able to do in your head, but I'm just trying to show you all the steps. So what does that mean z equals? 4. No. So that one, if you compare it to the last one, it definitely had less. It had less work in it. Okay. I can't put it all on the board, but it definitely had less steps. All right. Any question on that? Yeah.
If you had done in the first step, you had done 2 and 3 instead of 1 and 2, and it cancels out x, does that mix it up?
No, you can pick any of 2 equations to start with, and you can eliminate any variable you
Would
want.
that make it quicker though, because it would eliminate x in the first step?
Yeah, so if you eliminate x, I'd have to go through and see. So you eliminate x in equations 2 and 3. Is that what you're saying?
Because you have to change the z to a positive, which would cancel out x.
Yeah, it might make it quicker. I'm not sure. I'd have to see. But yeah. So that's the thing about these kinds of problems. There's lots of choices on how you solve it. Right? Tomorrow, we're going to look at, you don't have to write that, we're going to look at what's called a matrix. And what a matrix is going to do is it's basically going to make it so there are no choices in the problem. Everybody that solves it will end up doing it exactly the same way. Where the method I taught you today, some of you might say, well, I'm going to eliminate y in a different equation. We eliminated z, right? There were lots of choices. Okay, tomorrow's method basically takes out all the choices, and it makes it very systematic. Right? But this method always works. Okay, there's just more choices. All right. So that's the homework, just odds. Okay, so 1 through 21, just the odds. Some of those are 2 variables, some are 3. It's a combination of both. Okay, so when we come in tomorrow, we'll review. That's the only plan for tomorrow. We just review everything.